Cogito ergo sum. I think, therefore I am. Nowadays, we know more about the thinking process thanks to advances in technology with modern tomography and PET scans. We are able to identify exactly what parts of the brain light up while functioning. Now, we all know that the human brain is the end product of evolution. We literally have the reptilian instinctive brain, and on top of that, we have the mammalian, the mammal, hormonal, emotional midbrain. And on top of that, we have developed the neocortex, which has to do with the envelope that continued growing from apes onto man, but crashed into the rigid structure of the cranium, but had to wrinkle up with crevices and gyrus. Children, now we know, are born intelligent. Babies in uterus are known to respond with rapid eye movement, which is testimony of dreaming. Now, what it is that they are dreaming if they have never seen anything as of yet is something that is quite a debate. And some people think that there were past lives, or that they are processing internal responses to external stimuli. Whatever it is, babies are born with the total amount of neurons as an adult. However, they do not have interconnections between them. We develop axons and dendrites, which are the wiring structures that join one neuron to another. And from thence the word inteligencia, interligo, we join one neuron to another and create mental maps of association. This starts when a baby is born.
Underneath the newfangled cortex, the brainstem, the limbic system, and the basal ganglia date back to the mastodons, the dinosaurs, and the first amphibians. In humans, the old parts of the brain oversee emotion and help build memories. They control heart rate and breathing. They also form intimate connections with the new brain, the cortex. Though less than a quarter-inch thick, the cortex is the brain's crowning glory. Among its roles, the cortex is our reality check. It filters and orders the outside world for us and allows us to see, touch, hear, and speak. The cortex is also the human thinking cap. All our plans, thoughts, and ideas originate in this layer. The cortex is packed with nerve cells. About 2/3 of all our neurons operate here. A piece of cortex tissue, no larger than a pinhead, can house 30,000 of these cells. Each neuron has a job: to communicate with other neurons. The brain works by forming networks among these cells. The long, spiny branches of the network create a neural forest of astounding intricacy. Neurons use these communication lines to talk to each other with electric and chemical signals. Here under microscope are two neurons linking up. Though it may look like they fuse together, neurons don't actually touch each other. A closer look reveals that a tiny gap called the synapse separates their branches. This is where a message passes from one neuron to the next. The message comes from here, small sacs that store chemical molecules. When stimulated, these sacs release their molecules which cross the cell membrane into the synaptic gap. An electric zap allows this to happen. Meantime, the receiving neuron has special welcome sites for the incoming molecules. These receptor sites bind with the molecules. When they do, special gates open up. The gates let in a flood of charged particles, sodium and potassium ions, which start up a new electrical signal in the receiving neuron. This simple chain of events, an electrical zap, followed by chemical changes, followed by another electrical zap, is the basis of all brain activity. It's how neurons speak to each other. Here, then, is the key to the brain's complexity. There are 100 billion neurons in the brain. Each neuron, like a bit player in a grand production, processes its information, then hooks up with as many as 50,000 other neurons to send and receive messages. 100 billion neurons times 50,000 connections. It's this complexity that allows us to think imaginatively. On their own, neurons aren't very bright, but put 100 billion of them together in a small space and let them all start talking to each other, and you start to get brainstorms. The trillions of neural networks, like an improvisational orchestra, create new ideas and connect different thoughts in a whimsical and sometimes inspired fashion.
We also know that adolescents fully mature the frontal lobe, which is their capacity for abstract thought, until the 24 years of age. Intelligence, or the thinking process, is registered through electrical activity in the brain. Waves, however, differ. Beta waves are those that keep a baby alert. These are the ones that highly stimulate the attention deficit disorder in students. New mechanisms of biofeedback allow for students to develop alpha waves, which are more relaxed and allow concentration. Now, there are different types of unconscious waves. In altered states like meditation, or in light sleepers, or deeper sleepers, or in hypnosis. These are the delta waves. We talked about the three brains. Stimulus goes up the medulla and crosses first the instinctive hindbrain, and then it filters through emotions in the midbrain and goes up to neurons in the cortex to decide. Most stimulation of sexuality, addictions to alcohol or drugs, stimulate the midbrain. This is where neurotransmitters and hormones are stimulated. Either dopamine, which puts you on a high, or serotonin, which puts you on a low. We have identified different activities in the hemispheres. Left hemisphere innervates the right side of the body. This is where critical thinking, analytic thought, logic, language, science, written, math, and communication, right body control. This is the masculine controlling hemisphere. The right brain, which innervates the left side of the body, is considered to be the female brain. This is the non-critical, holistic vision of intuition that has a greater capacity for patterns, for creative reinterpretation. This is non-verbal, it's much more instinctive. And these are the differences which culturally define men and women. A man is taught to be analytic, much more sequential in linear thought, rational, very down to earth, verbal, cautious, math-oriented, science, a logic that is either right or wrong. And women are taught to be more intuitive, holistic, random sequencing, emotional thought, nonverbal, adventurous, impulse, creative. Both men and women have two hemispheres. Homosexuals have been found to have more interaction between both hemispheres. What is interesting to see is that the typical male brain has most of his connections running from the front to the back part of the same hemisphere, while women have connections very much like the homosexuals that go from side to side using both hemispheres. And this makes for a difference in the perception of the world. We see that men respond much more instinctively with the hindbrain, while women are much more tending towards the frontal lobe, which is abstract thought, patterns. As teachers, we are responsible for the wiring of significance given to the learning we are teaching. We have seen that there are different timings to learning. From 1 year to about 5 years, they see, they hear. There is visual cortex, auditory cortex. From 1 year to about 7 years, our students are more receptive to language and speech. And higher cognitive functions occur in our adolescence. There are different pathways for learning, and this is what makes for a difference in response. What is very interesting is that second language learners store the memory of one word in one language in a different place to the same word in a different language. This gives it a difference in significance and in perception, whether it be perceived or felt as something sensory, motor, something visual. You can literally see the passageway between the interconnection of one word being relayed to the other part of the brain according to cultural unconscious significance that we give every word. Now, words have been found to relate to the area of the brain where they are activated. If we are referring to a word related to legs, they appear in the motor part of the brain. If they are arm-related words, they are in the middle part, which literally activates the arms. The face-related ones are in the midbrain, the emotional center. Words occupy different parts of the brain as we give significance to them. This is what makes for subjectivity and for a difference in the learning timings of our students. Second language learners use more of their brain than one language speakers, and it allows them to recreate experience from a different angle, broadening their scope.